Assalamu alaikum wa rahmatullahi wa barakatuh. Now we're talking about chapter 4. Chapter 4, we finished the first two parts of it, which is the functional and non-functional requirement. We talk about the type of functional and non-functional requirement. And we said functional requirement, we try to accomplish it or we complete it in the logic of the program. And everything else, non-functional requirement, actually we fulfill it in the design. Like, example of non-functional requirement, the system shall be fast, the system shall be reliable, the system shall be dependable, whatever. Software requirement document, then the document or the outcome, the one it comes with it is really the document that capture complete description about how the system is expected to perform. And that document, it's been used by many different stakeholders, as we said before. Now we're talking about the requirement specification. Requirement specification, we're going to talk about, the ways of collecting requirement. And then after that, we'll go to the requirement engineering process itself, which it is requirement elicitation and analysis, requirement validation, and requirement management. As we said just a few minutes ago, requirement specification, it is the process of writing down the user and system requirement in a requirement document. That document, the one we're going to have it has to capture the complete description of how the system is expected to perform, functionally and non-functionally. User requirement had to be understandable, so it has to be easy to be understood by the user and the customer. And that's why we see that and the ways we collect these requirements. System requirements are more detailed requirement. Requirement may be a part of a contract for the software, for the system development. So the qualities of those requirements, it has to be correct, unambiguous, complete, consistent, verifiable, modifiable, traceable, etc., etc. As we explained, in the previous two lectures about, ways of writing system requirement, we said there are many different ways. One of them is, the natural language. Natural language are, written using number sentence. In a natural language, each sentence should express one requirement, no more. And it is written in the language of the user. Structural natural language, no, we take some of the freedom of the user and we put a standard form and we ask him to fill that form. And as we're going to see shortly, the form, it should have what is the requirement, what's the input, what's the output, blah, blah, blah. Design the description language, this is rarely used, so we are not going to cover it. Graphical notation, we'll cover it later on in this chapter as an example, which it is a use case, sequence diagram, whatever. And the last way or the last technique we use probably mathematical specification, and we are not going to cover it here. Since we are talking about requirement and collecting requirement, whatever, what is the relation requirement with the design? They tell you, they said here in principle, requirement should state what the system should do and the design should describe how it does. And actually, in practice, requirement and design are inseparable. You cannot segregate them. Why? Because while we are collecting requirement, we're thinking of a design. So we have a design in our mind. So a system architecture may be designed to structure the requirement. The system may be interoperate with other systems that generate design requirement. So we cannot collect requirement and then we go to the design and we find out that design or those requirements, they don't fit in the design, then we go back. So actually it could be done not really, they are not really interleaved. Like when we are collecting requirement, we have in mind what the design is. And when go to the design, we understand fully the requirement we collect because each of those requirement and design, they have impact on each other. The use of specific architecture to satisfy non-functional requirement may be طبعا a domain requirement. So some of the requirement, it is using a specific design. That's why they are inseparable. And this may be a consequence of regulatory requirement, some regulation, some legislative requirement, or whatever. Okay, the first way of collecting requirement is a natural language specification. Natural language is often used to write system requirement specification as well as the user requirement. However, because system requirements are more detailed than user requirement, so natural language specification could or can be confusing and really tough to understand. Requirements are written in natural language sentences supplemented by diagram and tables. The use of writing a requirement, this natural language, it's used because it is expressive. So everybody can express him or herself easily, intuitive, بديهية, and universal, عالمية. Yeah. If you understand the language, you could easily write your requirement. This means that requirement can be understood by the user and the customer. But since we said that it could be difficult to be understood, and the user and the customer, they have different terminology, different community, different way of thinking, it could have some problems. So let's put some guideline when you write that document. We could really invent a standard format and use it for all requirement. Use the language in a consistent way. Always use shall for mandatory requirement, and this is the conventional name. So in our project, we recommend you to reuse the shall for mandatory, the requirement which is the must requirement, and should for desirable one. Use text highlighting. If there is anything important in that requirement, go and highlight it. Put it in a bold, underscore, whatever, to identify the important part or the key part of that requirement. Avoid any computer jargon, as we said in the lecture. Terminology, slang, اللهجات المحلية, terminology. When we use the terminology, the user, probably user community and the IT community, they have different terminology. So don't use really my technical terminology as a user, because probably it means something different for him. Include explanation, rationale of the requirement, why that requirement is needed. As we said, it has some advantage, expressive, intuitive, and universal, but it has some disadvantage and it has some problem when you use the natural language. The first one is lack of clarity. Lack of clarity, it is sometimes difficult to use language in a precise way and unambiguous without making the document worthy and difficult to read by the customer or by us. Like example, if we mentioned a file, what do we mean by file? Is it text file, image file? What type of file is? The second problem, requirement confusion. Functional requirement and non-functional requirement, system goals and design information may not be clearly distinguished. You cannot really distinguish between this and that one, functional or non-functional. They mix them up. It is better to put non-functional requirement in a separate list than the other one. The third problem, requirement amalgamation. It's several different requirements may be expressed together as a single requirement. In one sentence, a customer could give you one sentence when really he tried to explain to you, or when you look at the requirement, when you look at that line, you could find many different functional and non-functional requirements, all of them written in one or two sentences. Let's look at the example of requirement for insulin pump, the case study 1. Requirement 3.2, the system shall measure. So we use the shall here. The system shall measure the blood sugar and deliver insulin, if required, every 10 minutes. Well, it's clear. But what's the rationale behind this one? Why 10 minutes or whatever? Between two parentheses, they put the rationale. Change is blood sugar are relatively slow, so more frequent measurement is unnecessary. Less frequent measurement should lead to unnecessary high sugar level. Another example, the system shall run a self-test routine every minute with the condition to be tested and the associated actions defined in table 1, whatever. The rationale of it, a self-test routine can discover hardware and software problem and alert the user to the function, the user to the fact that normal operation may be impossible. Well, because of the problem of the natural language, as we said, lack of clarity, amalgamation, requirement mixed up, whatever. So it is tough for us to compile all these requirements when it comes from many different users. So I think the other way of collecting requirement, probably we could really limit the writer to specific things when he write a requirement. So in other words, probably we could give him a form and he has to fill out that form. Structured language specification, it is a way of writing requirement in more formal and structured form. We use standard template. So we could really use a template specifying the requirement. Specification can be structured around the function or event performed to that system. It is an approach of writing requirement where the freedom of the requirement writer is limited and the requirements are written in a standard way. This works well for some requirement, which it is straightforward requirement embedded control system, but sometimes it is kind of rigid. It is difficult. It's inflexible to write business requirement because it has many different and complicated logic inside it. Now we are going to talk about, the form-based, the template you could really build, you could have. It doesn't have to be really all these elements in the template. You need a few of them, probably. It depends. You could really design your own template. It is good really to use such thing probably in your project. The first element is a definition of the function. The second one, the input, description of the input, description of the output, information about the information needed for, description of the action to be taken, the pre and post condition. That's if it is appropriate. Where we start and what's really the end. What's the one what requirement should be accomplished before it. Where we start actually to have the pre requirement is already accomplished and then we start them. And what's the post condition? And if any side effect is really if any for that function. If we look at example for structure template, structure specification template for an insulin pump, for the function compute insulin dose. The function, it is compute insulin dose. Description, compute the dose of insulin to be delivered when the current measured sugar level is in the safe zone between 3 and 7 units. What's the input? You need the current sugar reading, the previous 2 reading, of course from the memory, from history. The source, the current sugar, it comes from the sensor, and the previous reading comes from the memory. What's the output? You compute the dose. What the destination? Main control loop. If we look at the action here is the logic, how the computation it happens. And it is sometimes really difficult for the user to put it in a right way. If you read the action, look at it how complicated it is in this case. Compute dose is 0 if the sugar level is stable or falling, or if the level is increasing but the rate of increase is decreasing. If the level is increasing and the rate of increase is increasing, then compute or compose is computed by dividing the difference between the current sugar level and the previous level by 4 and rounding the result. If the result is rounded to a 0, then compute dose is set to the minimum dose that can be delivered. So it is really tough for me to understand this, or you or anybody, because it is complicated. As we're gonna talk about some model in the system analysis and design with the logic modeling, we have a model there called decision table. It's like, we use that decision table in case of we have compound condition. If A, then if B, then if C, then do so and so, else do something, else, etc. So we could really put it in a table. And here we call it tabular specification, which it is the third one, the one that comes soon, and we see how really we take these action and put them in a table, easy to be understood by me as a developer and by the customer who really put these rules. Again, the element to put requirement to previous reading so that the rate of change of sugar level can be computed. Precondition, the insulin reservoir should have maximum, at least the maximum allowed single dose. Precondition, post condition, I think we should move the current reading to the previous one and the previous one to the one even before it. Any side effect, nothing. As we said just a few minutes ago, tabular specification. Sometimes we find the logic so complicated. I think it's good, to use it in a table. If you have a compound condition, if A, then if B, then if C, do this. If A and B and not C, do something. If A and not B and C, do the third one, etc. So the tabular specification is used to supplement natural language, particularly useful when you have to define a number of possible alternatives. If you have many different alternative course of action, you use this one. For example, the insulin pump system bases its computation and the rate of change of a blood sugar level. And the tabular specification explains how to calculate the insulin requirement for a different scenario, as we're gonna see soon. If you look at this tabular specification of computation for the insulin pump, it is the same logic. So it is easy. It is put in a table. What's the condition and what's the action? If sugar level falling, this means if R2 less than R1, then compute dose equals 0. Else, if sugar stable, if it's R2 equal, then etc. So this is an explanation. What we have in the action in the previous example, we put it in a table. It's easy to be understood by you as a developer and by the customer who's writing that specification or telling you about that specification. Sugar level increasing and rate of increasing decreasing. It's mean R2 minus R1 less than R1 minus R0. Again, the dose is 0. If the sugar level increasing and the rate of increase stable or increasing R2 minus R1 greater or equal R1 minus R0, then you compute the round R2 minus R1 over 4. If round result equals 0, then compute equal the minimum dose. So it is easy really to be understood and to take this logic and put it in our language and in our program. Requirement engineering process. Requirement engineering process, the process of gathering software requirement from the user or the client, analyze and document them. The goal of the requirement engineering is to develop and maintain description of the system requirement document. The process here used in requirement engineering vary widely depending on the application domain. There are many different activities for when we talk about very widely. يعني تختلف كثيرا بين system و system. Depends on what? Application domain, people involved, and organization developing the requirement. But even with that differences, even with that variation for requirement engineering process, there is some generic activities we have for all processes of the requirement engineering. If we look at the activities here, I don't want you to get confused, because we saw in chapter 2 again requirement engineering process, and we saw the first process or the first activities was requirement feasibility study, and then the second one requirement gathering or elicitation, requirement specification, and requirement validation. And sometimes they talk about evolution and whatever. But requirement, we need to elicitate requirement, we need to analyze them using model, whatever, we need to validate them using the review. In the meantime, we need to manage them. So the activities are common. We need to find out if they are doable, whatever, which it is a feasibility study. But here, right away, we get to the elicitation, analysis, validation, and management. In practice, requirement engineering is an iterative activity in which these processes are interleaved. What do we mean by that? That elicitation, analysis, validation, management. Let's talk about the first three: elicitation and analysis and validation. When we elicit some requirement and we go to model and whatever, sometimes we find a problem. So we go and change the requirement elicitation. Then we go to validation. When we go to validate some requirement, probably we find a problem. So we'll go back to elicitation, analysis. So they are interleaved, متداخلات مع بعض البعض. كل الريكويرمنت، كل الاكتيفيتي الموجودة. And this is probably will answer, the interleaved, why or how really the process here are, or those activities are interleaved. If we go to the spiral view of the requirement engineering process, you go to the inner loop where we start. Then we find, the business requirement. This is an abstract requirement. And we see really if it is feasible or not, feasibility study. Then from the feasibility study, then we go and we have some user requirement with little more detail on it. And we come up with the user requirement specification. If we had any problem understanding, or we cannot do it or whatever, probably we do an prototyping. We say that in the third loop. Then we could, after we find out exactly what we want through the prototyping and everything is clear, then we create the system requirement elicitation. With the system requirement elicitation, we go and we specify it, system requirement specification and modeling. We put some model to it. Then after that, we'll go down to review it, and we go to the system requirement document. All this information has been put in system requirement document. So we start really with requirement elicitation, then requirement specification, then requirement validation, and أخيرا specific system requirement documentation at the end, which is just the one behind or outside the outer loop. If we go to the requirement elicitation, then this is, sometimes we call it requirement gathering, requirement collection, requirement discovery, whatever, all these kind of things. Involved, of course, some technical staff from our part as a technical people and our customer. What really the function, find out about the application domain. We try to find the domain, what's going on in that application. Services that the system should provide. And any constraint in that system. What really the constraint, what's the obstacles, what's the problem probably it could really encounter us in case of the operation. May involve, of course, who are the people are involved here: end user, the user system, managers, from our part in there, engineers involved in the maintenance, domain expert, which is the people in the domain, like the domain expert we talk about sometimes, like we mentioned so many times, you know, like people in the Bank Merkezi, central bank, you know, those they are expert in financial. Trade union, نقابات عمالية, etc. All these are interested, all these who are interested in the project, we call them stakeholders. Let's try to find out the first activity here, which is requirement elicitation and analysis. Software engineers work with a range of system stakeholders to find out. This means the stakeholder, the one we just mentioned now, we're gonna go and talk to them. Somehow there are many different techniques: interview, questionnaire, ethnography, as we're gonna see, which it is observation, etc. We're gonna talk about, you know, the application domain, services that the system should provide, the system, the required system performance, hardware, constraint, other system involved, etc. But when we talk about this one, we have to go through some stages. The first thing, we try to find out what requirement discovery, requirement gathering, what the system wants, what do you want. And probably we could accomplish this one by an interview. The system shall, the system shall, the system shall, the system. All these are requirement discovery. After we find all these requirements and we collect them and we have them, we go and classify them and organize them. Classification, this means, you know, we put them in many different categories. Example, if we collect requirement for a university system, we collect all requirement for the university. Then now we go and classify them. This requirement for registration system, this requirement for financial system, this requirement for financial system, for purchasing system, this is for library system, whatever. After we organize them this way, we then go, we prioritize them. We prioritize for each category requirement, those the one, the shall, the must do. Probably we could give them, you know, priority 0, 1, 2, 3, 4, 5, the important and the less important, until we get to the desired one, the wish list one, which it comes at the end of that list. Then after that, you know, we have to go and specify them. We have to go and put some specification in this requirement, because the requirement, it comes in one line. So we need really to specify it. What's the input, what's the output, what's the logic behind it, plus all these kind of things. If we look at this diagram, we see that, you know, requirement elicitation analysis process, the process of it, you know, how really we process it. We start with requirement discovery, then we go to the classification, then we go to prioritization, then we go to specification. If we have any problem with this, then we go. So we see it's an iterative. Let's see, when we specify it, we found there is a problem, there is a missing the requirement or whatever. So we could go and add it in the requirement discovery. And then after that, we classify it, then we prioritize it, then we negotiate it, whatever. Then we go and specify it. And so the process here, it is an iterative one. As we see it in the diagram, in the slide before, we see the requirement discovery, interacting with the stakeholder to discover, collecting the requirement from them. Then requirement classification, group related requirement and organize them into a coherent cluster. All these 10, 15, 20, 30 for requirement in one cluster. Cluster, it's like قطف, cluster of grapes. قطف عنب, we cluster them. Prioritization and negotiation, prioritizing requirement and resolve requirement conflict. Negotiate between us and the customer, or between the customer themselves with our existence there, to fix the problem if there is any requirement conflict between this customer and that customer. And finally, requirement specification, where requirements are documented and used as input into the next round of spiral. Requirement elicitation, it could have some problem. Why? Because, you know, we are technical, and as we said, and there are user community. They don't have the technical knowledge, and the same for us. We are, you know, as a technical community, we don't have the business knowledge. So sometimes probably we could have some problem. The problem with requirement elicitation, stakeholder do not know that what really they want. And we always say that. And sometimes some people, they were surprised. Because the customer come, you know, to work, and they do their work from 8 to 5 and they leave. They know how to use the system, but they don't know exactly why it works, how it works, what really they want. For us, we know, and we should know, because we know the technology and we know the business outside. We know the technology outside, if we have it, and we should know really what really they want. Not in detail, but at least we should know what. Stakeholder express requirement in their own language, and that's the problem that's the problem of natural language, the one we talk about. Different stakeholder may have conflict requirement. Of course, this department, they need the requirement to do so and so. The other department, they want another requirement which is contradict that problem. There is a conflict between organization and political factors. Sometimes there are organization and politics. They play a big role of system requirement. The requirement change. Sometimes requirement change during the time while we collecting requirement. Requirement change during the analysis process. New stakeholder may emerge. A customer, he told us, I need that and I need that. System should, the system shall, and whatever. And it looks like the customer is gone. He left the business. He left, you know, the company, and somebody else come, and then the new one, he will come with a different requirement. So there is many different problem we could face in this requirement. Okay, requirement discovery. Requirement discovery is the process of gathering information about the required and existing system and distilling the user and system requirement from this information. distilling تنقية ترشيح. يعني زي ما بنرشح المي، زي ما بنحط المية in filter, and then we get really the pure water. Here we need the pure requirement. So we need distill the user and the system requirement from this information. Because the customer, they give me information, I want blah blah blah. So I need to understand what really he wants and distill it and come up with a pure requirement. Interaction is with the stakeholder from manager to external regulator. Interaction, we need interact with manager, with the user, with the manager, with the sub-manager, with the domain, with all these people. We need to interact with them. System normally have a range of stakeholder, a lot of stakeholder. So we need really to interact with them, understand what really they want, understand that conflict they talk about, understand their language. And that is why when we talk about the ways of doing it, of collecting requirement, when we went from natural language to structure language, which it is the form, the structure language, it is the one we have a form. So we have to really distill, we have to come up with the requirement from them, what really they want. We have to understand it. Let's look at example here, stakeholder of the mental health care project management, patient management system. Patient management system, the one, you know, we talk about, case study 2. If you look at who are the user there, who are the stakeholder, who are the people who has an interest in that project, we find the patient, whose information is recorded in that system. We have doctors who are responsible for assessing and treating patient, nurses who coordinate the consultation with doctors and administer some treatment. We have the medical receptionist who manage the patient appointment. And we have the IT staff information technology staff who are responsible for installing and maintaining the system. We have also a medical ethic manager who must ensure that the system meets current ethical guidelines for patient care. We have a healthcare manager who obtain management information from the system. We have medical record staff who are responsible for ensuring that system information can be maintained and preserved, and that record-keeping procedure have been properly implemented. Well, in this case, for your project, you have to find out who are the user, who are the stakeholder. The stakeholder, as we defined before, everyone who has an interest in that project. And we talk about the stakeholder when we said there are 3 different categories. One of them is the active one, the driver, the one who give us the requirement, the one who drive the project to the right way, give us the requirement, do that, don't do that, etc. We have a supporter. Supporter is the management. The project is important for them, but they are not a driver. They don't give us any requirement, like the manager of the company, the president of the university, or whatever. And the third categories are the observer. The observer, the people who interact with the system, interact with the project, interact with the company, but they have no saying about any requirement for that system. Well, the first technique to collect requirement, to gather requirement, to elicit requirement are interviewing. Interviewing, it comes in 2 different, either interview one-on-one or one-on-many. This means we collect 4 or 5 user, and we have like a meeting with them, ask them a question, and come up with the information, the requirement from all of them at once. Interviewing, it's a formal or informal interview with a stakeholder are a part of most requirement engineering process. Formal, this means, we put a list of questions, we have a meeting with individual or group of people, and then we put 50-60 minutes and we collect requirement, we record some of requirement we want or whatever it is. And informal, it could be like, an informal meeting in the cafeteria, in the corridor. We find them, we just ask him, a question or 2, we could find out some requirement from him. What are the type of interviews? A closed interview and open interview. Closed interview based on a predetermined list of questions. This means we put some question, we have a special or specific meeting for 40-45 minutes at specific time, and then we ask the question after the other, and we collect all the information or the answer for it. The other type, open interview, where various issues are explored with stakeholders. We don't prepare any question, we go to the meeting and we just start saying some ideas, whatever trigger the meeting, and we start talking about that question or that thing, whatever. And as we're gonna see now later on about affecting interview, be open-minded and avoid preconceived ideas about the requirement. I mean, when you go there, you have to be open-minded. Yani don't have anything in your mind and try to go and to force it on those customer. And listen a lot. Prompt the interviewee to get a discussion going using them. Using what? Using a springboard question. Springboard question, this is probably for the open interview, where various issues are explored. We don't know. We don't have a set of questions. We don't have a set of questions to ask him. So we'll just go there, give him an idea, or we give him something there. A springboard question. Springboard, the springboard, that one, it is a spring, Zumba. Springboard, those people who swim, or al-ghattasin, whatever they call them, they just sit at that board and the spring will carry him 2-3 meters up there, and then they just go down to the lake or to whatever it is. So springboard question, requirement, proposal, or by working together on a prototype system, working together, all these kind of things, you know. Well, normally in practice, interview is really a mix of a closed and open-ended interview. Usually, interview are good for getting an overall understanding of what stakeholder and how they might interact with the system. As you said, usually it's a mix of closed, whatever. Probably we have a couple of questions we ask them, and then some idea comes to our mind or to them, or some word which trigger an idea. We start talking about it, and we elicit requirement. We gather some requirement from that idea. Interviews are not good for understanding domain requirement. Of course, the interview is good for the functional requirement. If A greater than B, how do we calculate that one? What kind of report you need? Blah, blah. But the domain requirement, it is, you know, it is by, as we said, it is by the expert. And we talked about it before, domain requirement. It is not easy to be understood by us. Why? Because it is implicit. Because the domain requirement, it comes from somebody who is who is an expert, you know, in that field. And when the expert, you know, talk, he always talks something. It is not easy for normal people to understand, and they always talk in an implicit way. Requirement engineer cannot understand specific domain, and some domain knowledge is so familiar that the people find it hard to articulate or think that it isn't worth articulating. Another technique is scenario. Scenario, it's a technique. It's like a storyteller. Tell us about a story about how really they do this from A to Z. And from that scenario, there are many different paths you go through. Scenario are real-life example of how a system can be used. The scenario should include a description of the starting situation, where we start. Then, the normal flow. If everything goes okay, if everything goes all right, then we do that, we do this, we do that, and then that's what really matters. What can go wrong? What really the problem we could have? And what if we had this problem? What if we counter some of these problems? Information about other concurrent activities. Other simultaneous activities doing in the same time. What really is going on in the same time, you know. We go do this requirement, in the meantime, we're doing other requirement in the same time, simultaneously, concurrently. Then the last one, a description of a state where the scenario finishes. So where we start and where we finish. What's the normal flow? What can go wrong? And what is the concurrent activities going on in the same time? Well, let's see the scenario for collecting medical history. It is good, you know, to read it as, you know, a scenario and try to find, you know, to get some requirement from it, whatever. Initial assumption, like the patient has seen a medical receptionist who has created a record in the system and collect. So the initial starting state, where we start. They tell you here the patient has been seeing the medical receptionist and record the system. The system information, collect all the information needed, name, address, age, etc. A nurse is logged on to the system and is collecting medical history. The normal activity, like the nurse searches for the patient by family name. If there is more than one patient with the same name, the given name, first name in English, and date birth are used to identify. The nurse choose the menu option to add a medical history. The nurse then follow a series of prompts from the system, enter blah, 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 information, free text, whatever. Then we continue with the scenario. What can go wrong? The patient record does not exist or cannot be found. The nurse should create a new one. patient record, patient condition, or medication are not entered in the menu. The nurse should choose the other option or whatever. Patient cannot or will not provide information medical history. The nurse should enter free text, whatever. Other activities record may be consulted but not edited by other staff. System state and completion. User is logged on. The patient record, including medical history, is entered in the database. A record is added to the system log showing the start and end time of the session and the nurse involved. Well, use case diagrams are used to gather the requirement of a system, including internal and external influences. أي تأثيرات داخلية أو خارجية فيه. These requirements are mostly design requirement. Most of them really design requirement, not really like a functional and detail requirement. So when the system is analyzed to gather its functionality, use cases are prepared and actors are identified. So we identify the actors, whatever. So use cases are a scenario-based technique in the UML, which identify the actors in any interaction and which describe the interaction itself. So we define the actor and then the interaction itself. A set of use cases should describe all possible interaction with the system. High-level graphical model supplemented by more detailed tabular specification, the one as we're gonna see it in detail in chapter 5. Then a sequence diagram may be used to add detail to use cases by showing the sequence of event processing in the system. And again, we don't want to talk about it now because we will cover it again in detail in chapter 5. Here an example of a use case for the mental health care patient management system. If we look at the patient management system, we'll find 4 stakeholders here. We have the receptionist, we have the nurse, we have the doctor, and we have the manager. Then we have many different processes like register patient, view patient info, view record, edit record, set up consultation, generate report, and export statistics. So all the functionality, I think we should define all the functionality. We should define the relation between these functions in the system, and then we could find out the actors. Who are the one who's going to use it in the system? It's like, if we look at an example here, medical receptionist. The receptionist, it has 2 things to do. One of them to register a patient, and one we could really view the patient. So she or he can register the patient. When register, walk in to the office, put the name, address, age, whatever, all these things. In the meantime, she could view the personal information of that patient. If we look at the manager can view the patient information, can export statistics, إحصائيات, أرقام, whatever about the patients, and it could generate some reports. If you look at the doctor, you see he could view the record of the patient, edit it, change, if he gonna put some treatment or whatever it is. He could set up some consultation for the patient, and he could generate report. The same for the nurse. The nurse, she could view and edit the record. Well, the last technique here we're going to use, in the requirement discovery are the ethnography. Ethnography, it is observation. Observation, we just go and observe the customer, how they do their work. With observation, we could put a lot of time in observation, or we could just put a minimum time for observation. Actually, we should really, understand what the customer doing, and just go watch him to see how he or she is doing it. And this is something to do with really like something to do with a social scientist. They tell you here, a social scientist spend a considerable time observing and analyzing how people actually work. People do not have to explain or articulate their work. Social and organization factor of importance may be observed. Ethnographic studies have shown that work is usually richer and more complex than suggested by simple system model. The main reason for ethnography, because sometimes you cannot, we as a human, it is tough for us to explain what really we're doing, what kind of job we are doing. We always abstract. We always forget something. That's why we need to go and observe how the customer is doing it. And with this observation, ethnography, we could find a lot of requirement the customer forget, or he or she think it's not really important to tell you about it. So observation, it is very important, but it is not used as a standalone. I think it should be supplemental to the interview. After interview, whatever, I think it's good to go and observe how really the customer doing their business. By now we end this lecture, and next lecture we go to the fourth part of the requirement.